Dear student, today we are discussing the 12th level chapter and the chapter name is linear differential equation. In this chapter, at first we are discussing the four types of linear equations and their solutions. And the types are, the first type is dy by dx plus py is equal to q types. This is the first type. And the second type is dx by dy plus p of x is equal to q. This is the second type. And third type equation is f dash y dy dx plus p times of f of y is equal to q. This is the third type. And now the fourth type, and the fourth type equation has an unique name, Bernoulli's equation. And the equation is dy by dx plus p of y is equal to q times of y to the power n. So today we are discussing these four types of linear differential equations and their solutions. So one by one we are discussing these four today with their example. Okay, move to the first part. Now we are discussing the first kind. In this first kind, that is dy by dx plus p of y is equal to q. Here if, that is the integrating factor, is equal to e to the power integration of p dx. This is the if. And now the solution will be y into if, that is a multiple of if, is equal to integration of q into if, that is the integrating factor dx plus of c, where c is a integrating constant. And now here p and q are the function of x or constant. So in this first kind, at first we want to find the if. What is if? if is equal to e to the power of integration of p dx. This is the if. if means integrating factor. And the solution will be y into if is equal to integration of q into if dx plus of c, where c is a integrating constant. And p and q are the function of x or constant. So this is the complete of the first kind, and we move to the example of the first kind. Now we are discussing the first example of the first kind. The example is dy by dx plus 2x by 1 plus x square times of y is equal to x square by 1 plus x square. So in this example section, if we compare this equation with the standard equation, then we get p is equal to 2x divided by 1 plus x square and q is equal to x square by 1 plus x square. This is the p and this is the q. Now if, that is integrating factor, is equal to e to the power integration of p. p means 2x divided by 1 plus x square dx. And now integrating this, then we get log of this one. By integrating this, we get log of 1 plus x square. And we know that the formula about e and log, this will be simple 1 plus x square. So if for the given example is 1 plus x square. So the solution part, solution y into if is equal to q into if dx plus of c, where c is the integrating constant. Now putting the value of if, y into 1 plus x square And now q is equal to x square by 1 plus x square, and if is equal to 1 plus x square, and dx is there and c is there. Now in the next, this one, and now integrating this will be x to the power 3 by 3 and plus c is there. So this will be 3 times of y into 1 plus x square is equal to x cube plus of 3c, where c is the integrating constant. So this is the complete of the first kind with their example. We move to the second part, the second kind with their example. So we move to the second part. Now we are discussing the second kind. In the second kind equation, dx by dy plus p into dx is equal to q, where p and q are the function of y or constant. And now if, that is the integrating factor for the second kind, is equal to e to the power integration of p dy. Here integration with respect to dy, and the first kind integration with respect to dx. So the solution of the given equation of that type, x into if is equal to integration of q into if dy plus of c. This is the complete of second kind theorems. Now we are discussing the one example of second kind. Now we are discussing the second example of the day. That is one example of the second kind. Here 1 plus y square dx is equal to tan inverse y minus of x times of dy. Now arranging this, we get dx by dy is equal to, now shifting this, we get, this is a standard form of the given example. Now comparing this with this, we get p is equal to 1 by 1 plus y square and q is equal to tan inverse y divided by 1 plus y square. So if is equal to, that is the integrating factor, if is equal to e to the power integration of p dy, that is e to the power integration of 1 divided by 1 plus y square dy. And after integrating this part, we get tan inverse y. So if will be e to the power tan inverse y. This is the if. That is a solution. X into if is equal to integration of q into if into dy plus of c, where c is a integrating constant. Now putting the value of if, we get x into e to the power tan inverse y, and putting value of q is equal to tan inverse y divided by 1 plus y square, and if is equal to e to the power tan inverse y dy, and c is a constant. So after integrating this part by parts, we get x into e to the power tan inverse y, and this part gives us is equal to e to the power tan inverse y times of tan inverse y minus of 1, and c is there, plus c is the integrating constant. Now this is the complete of the second example. So this is the complete of the second kind. Now we move to the third kind. Now we are discussing the third kind. This third kind, that is f dash y times of dy by dx plus p into f of y is equal to q, where p and q are the function of x, and putting of y is equal to z. This is the formula for the third kind, and the example of third kind we are discussing 1 by y cube times of dy dx plus 1 by x times of 1 by y square is equal to x square. Now putting this one, f of y is equal to z, f of y is equal to z, that is this one, 1 by y square will be z here. After putting this and derivative this, we get dz by dx minus of 2 by x times of z is equal to minus 2x square. And now integrating factor of this equation will be e to the power integration of p dx. P is equal to minus is there, minus 2 by x dx. Now integrating this part, we get e to the power minus 2 times of log x. So we get this will be x to the power minus 2. So the solution will be, there is this equation, solution of this equation will be d of z times of x to the power minus 2 is equal to minus of 2 times of x square, 2 times of x square multiple with x to the power minus 2 dx, and c is the integrating factor. Now integrating this z into x to the power minus 2, and this will be x square, this vanish, minus 2 is there, this will be the x and this is the c. Now putting the value of z, we get 1 by y square, and this will be 1 by x square, and this will be minus 2x plus c, where c is the integrating constant. This is the complete of the third. Now we are discussing the 4 types of linear differential equations. 4 types, these are Bernoulli's equations, and the equation is dy by dx plus p times of y is equal to q times of y to the power n, whereas p and q are the function of x. Now arranging this equation, we get this, that is y to the power n y to the power minus n times of dy dx plus p in y to the power 1 minus n is equal to q. And now putting y to the power 1 minus n is equal to z. Then after derivative this part, we get this, and putting this part in the equation number 1, then this equation will modify it as this one. This will be the 1 by 1 minus n times of dz dx plus p into z is equal to q. After modifying this part, we get this, that is the dz by dx plus 1 minus n times of p into z is equal to 1 minus n times of q. And this equation, that is the equation of the first kind. So this is the first kind equation, dy by dx plus p of y is equal to q. Here dx and replace y as a z, dz dx, and p is there and y is replaced by z, and 1 minus n will be the constant part, and q is a function of x. Here the q is a function of x, here q is a function of x with the multiple with constant part 1 minus n. So this kind of equation will be solved as equal as the first kind. So 4 types equation will be converted with 1 types equations. This is the complete of today's sections. Today we are discussing the linear differential equations and their 4 types of equation and their solutions and the process of solution. Hope today's discussions with the example will help you to understand this chapter. There is the linear differential equation chapter, and when you practicing this chapter in future, this video help you to understand this chapter and extend your knowledge about this chapter, and help you to solve this kind of equation. There is a 4 types of equation of this chapter.